Pick an airport. Pick another airport. Draw a line between them. Now you've started planning across country. You will need a couple things to plan across country. First of all, a sectional, then a plotter, an E6B or an electronic calculator, and a Navlog where you can record all your data, as well as winds aloft and airplane performance data. I do know that iPads and ForeFlight exist, and I can use them fairly well, but you need to know how to use a sectional and how to use the information on it to plan a cross-country flight. There is a really good chance you will be required to do this for your practical test. I know for most of your flights after the practical test you'll be using ForeFlight or something similar, and that's fine, but you should know how to do the nitty and gritty and plan a flight. You might see pilotage and dead reckoning being used. Pilotage means using the sectional and your surroundings to find where you are, and dead reckoning means using a little bit of math to find where you will be flying this heading at this altitude, this speed, and for this amount of time. We'll use both of them planning across country, and you'll use them as you fly as well. For your training for across country to count, at least one leg has to be 50 nautical miles. If you're not working towards a certificate, across country could be as little as, 1 mile if the airports are super close. Let's plan across country. As a fair warning, planning across country takes a bunch of information from a lot of different sources and puts it all together in one little space. I've tried highlighting and circling just to make things easier for you to see. Stick with it, it will make sense. Here are the 3 airports we're going to fly in between. We'll start at Dodge City Regional, then we'll fly over to Pratt, and then Meade and back to Dodge City. The first step is drawing a line between your departure airport and your destination airport. And the second is finding waypoints in between. You need waypoints for pilotage to make sure that you're still on the route that you're supposed to be on. Good waypoints are things that you can easily see from the airplane, and they're about 10 to 15, maybe even 20 miles out if you can't find anything in between. Starting at Dodge City Airport, the very first waypoint I picked is the stock pens and the bridge over the Arkansas River. The second waypoint is the Arkansas River itself, right when you cross it. Next we have Highway 183 that you will cross, and you should definitely see that from the airplane. And then finally you'll be abeam the town of Cullison or something like that. And then you'll be landing at Pratt Airport. If you notice, I placed little dash marks that are perpendicular to that line, and that will represent the wings of the airplane as you pass over these fixes, and that'll make things easier when you try to figure out if you're on time or a little bit behind once we do the navlog. Our second leg is a little bit longer. We'll start at Pratt Airport and we'll go over to Meade Airport. Once again, we'll use Cullison as that first waypoint. The next one I've got is the town of Greensburg. And you might say, well, isn't there an airport that you're going to fly right next to? That is true, but it's an unpaved airport and it might be a little bit hard to see. Now, I did go on Google Maps in the satellite view and tried to find that airport, and I could not find the airport at all. Moving on, the next thing I have is Mullinville, that's a city. The next thing I have is the city of Buckland. You can also see 2 highways intersecting in a 3-way intersection, so that's a good waypoint. Also, I don't know if you've noticed, but you will be paralleling a fairly decent sized highway, so you'll be flying parallel to that Highway 54 that turns into something else later on. Now moving on down, I've got the city of Bloom. You'll be right abeam the city of Bloom, and you'll be pretty much right over the private airport there if you can find it. And then finally I have the town of Fowler and an elevator if you can see it, and that airport you might actually be able to pick up. And then the destination or Meade. And then for our last leg I have Meade as the starting point, and then going over Fowler again you'll see the city of Fowler. The next waypoint is abeam Ensign, and you might be able to see some of those towers. And then Dodge City. So as you can see, we have a waypoint about every 10-15 miles or so, then maybe a little bit further apart if there's not a lot of good waypoints. I want to caution you that just because something looks good on a sectional chart doesn't mean you will find it. And believe it or not, airports are actually harder to find when you get to them. So that's why it's a good idea to look at Google Maps before you go, just to kind of get a layout of what you're looking for. And now on to the navlog. This will probably be the longest and the hardest flight planning process, and there's no better way of doing it than just jumping right in. On the left hand side we will list all our checkpoints that we came up with, and you can name them however you want. Now the next thing we need to do is figure out what our course is from one airport to the next. The way we do that is we take our plotter And we line up the course with the little course arrow right on top of the ruler. And then you also want to make sure that the center dot lines up with one of the lines of latitude or longitude. And once you get it all lined up and squared away, you can look at the circle part of the plotter and you'll see what the course is for going from one airport to the other. Just make sure you look at the correct direction. For our route of flight, we're going to the east, and that is 095. The next thing we can do is measure distances between our waypoints. The distance column is further to the right, and you can put the total distance up at the top. And with your plotter, if you line up the bottom of it, it's the sectional scale. And if you put one end on the center of the airport and line up the plotter with the airport on the other side, you can see that the distance is 58 nautical miles. And we can go ahead and fill in the rest of the distances. So from Dodge City to those stock pens, it's 11 miles. And that gives us 47 miles to go. And then 9 miles for the next two waypoints, that leaves us with 38. And then 10 miles leaves us with 28. 20 miles between the highway and city of Collison, and then 8 miles to the airport. And that leaves us with 0 miles remaining. So now we have our course and we have our distance. Next thing we need to do is figure out our cruising altitude. Now our flights are fairly short, so there's not much benefit in picking a better altitude for better winds. So we'll just pick it based on the direction we're going. In the first leg we're going to the east, so we need to be at 5,500 or 3,500. And if we look around, our highest safe altitude is 3,200. And so 3,500 would be pretty close to the highest obstacle, so we'll pick 5,500 going east. These blue circles represent where the wind data is coming from. So for the first half of our leg, we'll use the Garden City GCK winds, and then for the second half, we'll use ICT winds. If we look at our winds aloft, GCK says that at 6,000 feet, winds are at 310, 17 knots, with a temperature of plus 17. Going further down, we'll use the winds from ICT, which are 260 at 19 with a temperature of plus 16. So now we have our distances, our altitude, our course, and our winds. Our next column in our navlog is the true airspeed, and we can find that by looking at the performance charts for our Cessna 152 in this example. For cruise performance, you see that there's an altitude listed, and then there's 3 different columns, 20 degrees below standard and 20 degrees above standard. So we need to figure out what standard temperature is at 5,500 feet and see where we fall. Temperature decreases by 2 degrees every 1,000 feet, so at 5,500 feet it should be 10 degrees lower than standard. In other words, it should be 5 degrees. If we look at our winds aloft, it happens to be plus 16 or plus 17 depending on which wind you look, which means it's about 10 degrees above standard. That puts us in between the standard temperature and the 20 degrees above standard, and so we can interpolate if there's a big difference. So looking at 6,000 feet, we'll be cruising at around 2,300 RPMs. And looking at our true airspeed, that's either 95 with the standard or 94 with the 20 degrees above. So we'll go ahead and we'll take 94 since that's the worst performance. The next section on your navlog is this TC, TH, MH, CH, all these random letter things. What that stands for is true course, that's TC, and that's the course that we measured from one airport to the other one. If you take your true course, that course that's based on true north, and you add a wind correction angle to it, you end up with a true heading, or a heading based on true north. Then if you add the east and west magnetic variation, now you end up with a magnetic heading. Then the very last thing we have to do is add the compass deviation, and you get a compass heading. So now you have a heading to fly when you go and do your cross country. This is where our E6B comes in, and we'll use the backside of the E6B first. Up on the top you have directions on how to use it, and it's actually very useful. The very first thing it says is set wind direction under true index. The inner ring spins and we can set 310 in for the wind direction. Number 2, it says mark wind velocity up from center point. So usually I set the center at 100 and then mark how many knots of wind it is from 100. So in this case it's 17 knots, so you place a little dot at 17. Next we set the true course under our true index. Our course is 095. Next thing it says slide wind velocity mark to true airspeed. So we slide our wind mark that we made up to our true airspeed, and in our case it's 94. Ground speed reads under center. If we look under the center, it looks like 108 is what our ground speed will be. And number 6 says wind correction angle reads between center line and wind velocity mark. Going left and right you have degrees, and if we count we have 2, 4, 6 degrees off to the left. So our wind is coming from the left and we have to change our direction by 6 degrees to compensate for that wind. If you look either on the E6B or on the Navlog, it says that for a left wind you subtract the left and you add the right. So we'll do -6 on our Navlog, and that makes our true heading 089. The neat thing about the E6B is that you can easily tell where the wind is coming from. If you imagine yourself as that center circle, the wind is coming from the left and from behind you, so it's a left quartering tailwind, and you should be going faster than your true airspeed because the wind will be pushing you. The next thing we have to add is the variation, magnetic variation. If you remember, is on the chart with that dashed magenta line. If you look carefully on the map, you have a 5 degree 30 minutes east, 5 degrees, and 4:30 east. And we'll go ahead and we'll just use the 5 for easy math. Once again, if you look at your Navlog, it says for an easterly deviation you subtract and you add the west. So 089 minus 5, that gives us a 084 magnetic heading. And the very last thing we have to do is correct for our magnetic deviation, and that's based on the electronic things inside your airplane that mess with the compass, and that's why we have a compass correction card. Looking at this one, it says for flying to the east you steer -1 or 1 degree less. So we'll go ahead and we'll subtract 1, and that gives us our compass heading of 083. So when you go fly your cross country, you fly a heading of 083. Let's go ahead and do the next calculation for halfway through, where we're going to switch to the other wind station. And those winds are 260 at 19. So once again, we'll set our wind direction under the true index. We'll mark 19 from 100, so 119. Then we'll spin the inner circle until it's lined up with our true course, once again 095. And we'll slide up the mark that we made up to our true airspeed. So now we have our ground speed of 113 knots and a wind correction angle from the right. Now we have a right quartering tailwind. So if we put everything in our Navlog, you have a true course of 095. We will add +3 for that wind correction angle from the right. It gives us 098, and then we'll subtract 5 for magnetic variation. Gives us a 093. And once again -1 for the compass deviation. That gives us a compass heading of 092. Have you gotten super confused yet? Don't worry, just wait a few minutes, it's about to happen. Let's flip over the E6B to the other side. I would recommend that you read the E6B manual because it'll explain a lot more stuff than I can in a short little snippet. But the front face has a bunch of numbers and they're all lined up right now. The key to understanding the E6B is that the numbers are multiples of 10. Or rather, the decimal place can move. So for example, the 10 that's outlined in black, that could be 10, that could be 1.0, that could be 0.1, could be 100, 1000, etc. So it's a multiple of 10, and that goes for all of those numbers. Let's do a little example so you can see how this works. There's a little cheat sheet, if you will, at the bottom of the inner circle in the E6B, and it says you set your speed against the arrow, or the rate arrow, and on the outside you'll read the distance, on the inside you'll read time. So let's do something really simple. Let's say you are flying at 120 knots. So we'll go ahead and we'll move our rate arrow up to 120 knots. And let's say you fly for 2 hours. So on the inside you can find either 2 hours or 120 minutes. And on the outside you can see that you will go 240 miles. If you're flying at 120 knots, that's where our rate arrow is, and you go for 400 miles, that'll take you about 3 hours and 20 minutes, or 200 minutes. Something to keep in mind is the scale. As you can see from 10 to 15, the scale is a little bit smaller. 15 to 30, there's another scale, and then 30 on, it's a little bit different as well. So just keep in mind that sometimes it's 0.1, sometimes it's 0.2, sometimes it's 0.5. You can also convert units. If you set a number against the nautical portion, you can convert it to statute. You can also set a number of US gallons, and on the opposite side you can read how many pounds that is. So it's a very neat and handy thing, but for now all we're going to use it for is to figure out how much fuel we'll burn and how fast we're going to get from point to point. Before we start using the E6B, let's go back to the POH and look at some additional information. This chart here tells you the time, fuel, and distance it will take to climb. We need to figure out how much fuel we'll use on the climb out. If you look at the chart, the elevation of our airport is 2,596 feet. We'll round that to 2,500, and we're climbing to 5,500 feet. So we need to interpolate a little bit of data to get those numbers, and then the way it works is you take your cruising altitude and you subtract the numbers from your elevation or where you are, because you're not climbing from sea level, you're climbing from that elevation. So at 5,500, it says that it'll take about 9 minutes to get there. We'll use about 1.3 for fuel, and that'll take about 11 nautical miles to climb there. At 2,500 feet, that's 4 minutes. Let's call it 0.6 for fuel and 4 minutes. So if we go ahead and subtract, that's 5 minutes, 0.7 gallons, and 7 minutes. If we look at our notes, number 3 says increase time, fuel, and distance by 10% for each 10 degrees above standard temperature. Now at 5,500 feet, the temperature is supposed to be 4 degrees, and we know that it's going to be 17 based on our winds aloft. So that's 13% more for each one of those. So if we add that factor, that's 5.6 minutes, 0.8 on the fuel, and 8 nautical miles. Note number 1 says that we need to add 0.8 of a gallon of fuel for start, taxi, and takeoff, and that's to do your run-up and taxi to the runway. So we'll go ahead and add 0.8 to our 0.8, and we have 1.6 on the fuel. We'll save these numbers because they will come into play a little bit later, but for now let's look at the sister chart over here, cruise performance. We looked at it before, but now we have to look at our RPM and the altitude and figure out what our fuel burn will be at that altitude. We're still at 13 degrees above standard, so we'll go ahead and interpolate, and our fuel burn will be 4.8 gallons per hour. So now then, equipped with all these numbers, we'll go back to our Navlog and try to make sense of it all. We can put in our fuel flow under the gallons per hour column. And now the fun part, now we actually get to use the calculator side of the E6B. Let's skip the first leg for now. This is where we had to do the calculation for the time, fuel, and distance to climb. We'll go to leg number 2. Leg number 2 is 9 miles long, and we're flying at a ground speed of 108 knots. So we can set our rate arrow to 108. So that's right before the number 11, 108 knots. And then if we look on the outside for our distance, we should get the time on the inside. So if we look for 9 miles on the outside, that's 90. It happens to be right at 5 minutes. So it'll take us 5 minutes to go 9 miles at 108 knots. We're going to leave our arrow where it is, and we'll look at the next leg of 10 miles. And for 10 miles, it looks like 5.55. I usually round to the next decimal, so 5.6 minutes is what it's going to take. Now our winds change, so let's not forget to change our ground speed, and the ground speed is 113. So we will move our rate arrow to 113. On the outside we'll find 20 miles, and that looks like 10.55 or 10.6. And finally our last leg is 8 miles, so if we go find 8 on the outside, on the inside it happens to be 4.3. So now we have our time. Next thing we need to figure out is how much fuel we'll burn in that time. We figured out our fuel burn is 4.8, so we can move our arrow to 4.8. This will get a little bit tricky just because our fuel burn is so low, so make sure you do a little logic test when you do the math. So at 4.8 gallons per hour, if we go for 5 minutes, time is on the inside, you get 40, or 4.0 or 0.4. Let's do a little logic test. At 4.8 gallons an hour, we won't burn 40 gallons. It's also not likely that in 5 minutes we'll burn through 4 gallons if our burn is 4.8. So it's 0.4. So we'll burn 0.4 gallons in 5 minutes. Leaving our arrow where it is, we'll go look for 5.6 minutes. That happens to be 0.45. We'll round that to 0.5. Next we have 10.6 minutes, and looking at that it looks like it's 0.8586. We'll just round it up to 0.9. And finally 4.3 minutes, that happens to be right at about 0.35. We'll round it up to 0.4. I always try to be a little bit more on the conservative side, so 0.4. And now we can go back to our first point. The reason I left it behind is because there's a little bit of calculating. The first leg is 11 miles, but we know that we'll be climbing for 8 miles off of that time, fuel, and distance to climb chart, which means we have 3 more miles to climb. At our ground speed of 108 knots, that will take 1.7 minutes, which means the total time will be 7.3 minutes for that first leg. And as far as fuel, if we take our fuel burn of 4.8 and go for 1.7 minutes, that's 0.13 or so. We'll round it to 0.2. So 1.6 plus 0.2 is 1.8 for the fuel for that first leg. If we add everything up, that's 33 minutes for flight time and 4 gallons for fuel. Now the rest of the empty columns that we left, for example, all the courses, altitudes, wind, all that all stays the same for all those other legs. If you were to make a turn or if the wind changed, then that's where we start the new data. So in other words, we're assuming everything below our first line of data is the same. Now for the ground speed, we put in our estimated ground, that's the top line. As you're flying, you can recalculate it and see what the actual is, and you can write that in on the bottom. And the same thing goes for time. You can write in your time off or when you took off, and then add the leg time to it, and you can see what time you should be over your waypoints. And as you cross your waypoints, you can see if you're ahead of schedule or if you're behind. Also the VOR column, you can put in the VOR and the radial you will be on. That way you can triple check your position. I hope you were paying attention in this video because the next 2 legs are left blank, and it's up to you to fill out all the other information. The only thing I'll put in there are the waypoints, your course, altitude, winds, and the leg distances. And you have to figure out all the heading, ground speed, fuel burn, all of that stuff. In the description box there will be a link to a POH, the online EFB simulator. You also have access to a Navlog, and then also there will be an answer sheet where you can see if you got your numbers right. Now don't give up and say, yeah, I kinda know how to do it. Go and actually do this. This is a free sample problem. If you can do it, the simulated cross-country planning for your check ride is going to be a breeze. And that, my friends, is how you plan a cross-country. Until next time, have fun, fly safe, and always keep learning.